The sun should have swallowed it whole. Yet against every prediction, the object designated 3I Atlas didn't simply vanish. It fought back, burning brighter, fragmenting, and then changing. When astronomers first spotted it, they thought it was just another interstellar visitor, a silent traveler like Oumuamua or 2I Borisov, drifting through our solar system before fading into the dark. But the moment it began its plunge toward the sun, telescopes across Earth caught something that defied every model we had for such objects. It wasn't behaving like a comet, nor like an asteroid. It was resisting. Images from SOHO and stereo satellites revealed a trail of ionized dust unlike anything recorded before, patterns twisting and reforming as if magnetic forces were rewriting its structure mid-flight. Its tail didn't dissipate. It pulsed. Some frames even showed flares emerging ahead of the object, as though it were interacting with the sun's field in real time, fighting against annihilation. Astronomers expected a quiet fade-out. Instead, the sky lit up with data, temperature spikes, polarization anomalies, and a motion pattern that didn't fit any gravitational trajectory. Something inside that object was holding on. And then came the most haunting observation. Its core temperature didn't just rise. It oscillated rhythmically, as if something beneath the crust was alive with reaction. Not biological life, of course, but a form of persistence, a kind of coherence we don't see in inanimate matter exposed to that much heat. What exactly was 3I Atlas made of? And why did it behave as though the sun wasn't its end, but its transformation? The first official detection of 3I Atlas came in 2020 through the Atlas Survey in Hawaii, a system designed not to study stars but to defend Earth from asteroids. At first, astronomers logged it as an ordinary comet, faint, diffuse, and moving on a steep, hyperbolic trajectory. That last part was the clue. The same kind of path that defines an interstellar traveler. This wasn't from here. The orbital analysis revealed a trajectory too eccentric to belong to our sun's gravitational family. Its speed, more than 30 kilometers per second beyond the sun's pull, marked it as the third confirmed interstellar object ever observed, hence its name, 3I. But the mystery began when its coma and tail started acting like they belonged to something we didn't yet understand. Typically, when comets approach the sun, they release gas and dust from frozen volatiles like carbon dioxide or ammonia. But spectroscopy from the Very Large Telescope and follow-up observations from SOHO indicated something unusual. The gas composition was inconsistent with standard solar system ices. It lacked the expected cyanides and water vapor lines. Instead, the emission spectra showed metallic ions, magnesium, iron, and an unidentified peak near the infrared range that matched no known element ratio. Then came the thermal data. As 3I Atlas approached its perihelion, models predicted complete disintegration. Its nucleus should have broken apart like a snowball under a blowtorch. But what happened defied thermodynamics as we know it. It did fragment, yes, yet parts of it maintained cohesion, glowing at temperatures far beyond what carbon-based compounds could endure. Some researchers proposed it was rich in refractory materials, perhaps silicates forged in a supernova's ejecta, or even remnants from a planetary crust ejected from another system. Others speculated an even stranger origin, a magnetized composite, similar to metallic hydrogen or exotic carbides that could only form under immense pressure, like the cores of neutron star planets. Solar physicists then noticed something no one expected: interaction signatures. The plasma tail wasn't just being shaped by solar wind, it was actively distorting the field around it. Imagine a rock that not only melts in fire, but bends the flames themselves. The data implied a magnetic moment, as if 3I Atlas carried its own residual field, generated either by rapid rotation or internal structure, unlike any known comet. For a brief moment, instruments recorded flickering radio frequencies, synchronized with its oscillating brightness, a pulse that hinted at an organized pattern rather than random chaos. Whatever 3I Atlas was, it wasn't merely burning, it was responding. And as it neared the sun's crown, that response revealed a behavior that forced astronomers to question not only what it was made of, but whether it was built for exactly this kind of encounter. For decades, we've comforted ourselves with a simple idea. Space debris is just that, debris. Rocks, ice, dust, wandering through a vast and indifferent void. But 3I Atlas refused to behave like anything dead. In the days following its closest approach to the sun, data began contradicting everything our models assumed. Its trajectory, initially smooth and predictable, began showing micro-deviations, small but consistent thrusts that didn't align with solar radiation pressure or outgassing jets. The standard cometary physics couldn't explain them. It was as if the object were subtly steering itself. That single anomaly cracked open a deep illusion in astronomy. The idea that interstellar objects are passive relics. For centuries, we've imagined them as frozen witnesses of ancient cosmic events, fossils drifting between stars. But the signals coming from Atlas hinted at something dynamic, something that might even be reactive. An analysis from ESA's Solar Orbiter team revealed that, as Atlas disintegrated, the fragments followed synchronized paths, maintaining relative spacing even as solar winds battered them apart. That's not normal. Debris doesn't choose to remain coherent. It scatters chaotically. Yet 3I Atlas's pieces behaved as if bound by an unseen geometry. Some astrophysicists suggested plasma coupling, a phenomenon where electrically charged fragments maintain cohesion through induced currents. But the energy required for that stability exceeded what the sun's field could provide. So the question grew darker. Was Atlas generating its own field? That's where the illusion truly broke. Because if it was, then we were witnessing an object capable of internal energy regulation, not intelligent necessarily, but self-stabilizing in a way that blurs the line between natural and engineered. In a lab at the Max Planck Institute, researchers tried to replicate the emission spectra of the object using magnetized silicates and doped carbides. None matched the wavelength pattern observed. Even stranger, when they simulated its trajectory with full solar radiation pressure models, the only way to reproduce the recorded deviations was to introduce an artificial torque, like the push of tiny periodic jets, perfectly aligned with its spin axis. That spin axis was pointing directly toward the sun. It's easy to dismiss speculation in science. Data is sacred, imagination dangerous. Yet 3I Atlas forced both to coexist. If it was merely rock and ice, why did it display coherence patterns reminiscent of active stabilization? If it was artificial, how could it endure temperatures that no known alloy could survive? Perhaps we were looking at neither a ship nor a comet, but something older, a remnant of processes we've yet to name. As the sun's radiation flayed its surface, 3I Atlas wasn't breaking down. It was revealing its true composition, layer by layer, as though the star itself was peeling away the illusion. And buried beneath that fiery skin, astronomers detected one final signature, a repeating spectral line that didn't belong to any known element in the periodic table. The first clue came quietly, a sequence of thermal spikes recorded by SOHO's LASCO C3 coronagraph. Every 11 minutes, the brightness of 3I Atlas surged and dimmed in perfect rhythm. At first, it seemed like noise, a calibration error. But when the same pulse appeared in data from Stereo's twin spacecraft, separated by millions of kilometers, coincidence was ruled out. The pattern was real. Observation. Pattern. Every oscillation corresponded to a fluctuation in its plasma envelope, almost like a heartbeat. Not chaotic, not random. Deliberate in frequency. The repetition continued for nearly 36 hours, long after solar radiation should have stripped the object to vapor. Astronomers plotted the intervals, and one number stood out, 660 seconds between peaks, identical to the magnetic oscillation period predicted for conductive materials rotating within a stellar corona. If true, that would mean 3I Atlas was interacting with the sun in a resonant state, like a tuning fork vibrating in harmony with solar magnetism. Nothing natural we know of behaves that way at those distances and temperatures. Pattern. Hypothesis. Teams from NASA's Goddard Space Flight Center and the European Southern Observatory began comparing the readings to laboratory models. They discovered that only structures composed of layered conductive lattices could exhibit such sustained resonance, materials engineered to distribute heat and electromagnetic stress evenly across their surfaces. In other words, a design optimized to survive near a star. Was it possible that 3I Atlas was a fragment of something larger? A relic built not to avoid stellar destruction, but to endure it? Hypothesis. Implication. If Atlas was artificial, then it wasn't merely a visitor. It was a messenger of physics itself, a survivor of stellar birth or death, or a remnant of a civilization that understood the sun not as a threat, but as a power source. Researchers attempted to decode the strange spectral line that accompanied the object's pulsing. It appeared near the infrared, just below 1.3 micrometers, too long for common metals, too short for organics. The best fit came from a hypothetical alloy called silicene-graphene composite, theorized to exist under supernova compression, but never observed in nature. If that was correct, the material could convert extreme thermal gradients into electromagnetic oscillations, essentially a self-cooling mechanism, which means the object wasn't just surviving, it was adapting. As Atlas drifted out of solar range, fading into the heliosphere, fragments continued to emit that same rhythmic signal, weaker but still coherent, like embers whispering after the fire's gone. No telescope captured its final state. The last reading came from the Parker Solar Probe's magnetic sensors, a faint echo matching the same 600 to 60-second period receding into silence. Implication, reflection. We used to believe the sun destroys everything that approaches it, but maybe for 3I Atlas, destruction wasn't the end. It was a form of communication, a way of revealing how matter, when perfectly organized, can transcend the boundary between burning and becoming. The notion that something could endure, even thrive, in the heart of the sun unsettles our deepest assumptions about existence itself. Every model of survival we've ever known is built around avoidance. Avoid fire, avoid collapse, avoid annihilation. But 3I Atlas seemed to follow the opposite rule. It didn't flee the source of destruction. It moved toward it willingly, and that changes everything. Because if matter can adapt to the sun, if it can reorganize itself under conditions that should erase all structure, then perhaps our understanding of death in the cosmos is too narrow. We see entropy as the end, the unmaking of order. But 3I Atlas hints that entropy may have gradients, thresholds where matter reorganizes itself into new forms of stability. In that sense, what we call burning could be an advanced form of transformation. Philosophers of science have long debated whether the universe evolves through chaos or design. 3I Atlas adds a new possibility: resonant evolution. Matter finding harmony within extremes. The same physics that kills lesser structures might, for the right composition, become the source of coherence. Skeptics were quick to respond. Many argued that the object's pulse could be an observational artifact, a byproduct of data compression or instrumental shadowing. Others claimed it might simply be fragment rotation, creating optical modulation, a trick of geometry, not intelligence. And yet, none of those explanations accounted for the spectral consistency across multiple instruments, nor the magnetic perturbations recorded independently by solar probes. Even if every anomaly could be explained away, the philosophical shock remained. The sun, that ancient destroyer, may not be the executioner we think it is. It could be a sculptor, reshaping matter into higher states of resilience. And if that's true for rock and metal, what about consciousness? It's an unsettling parallel, but not an accidental one. Humans have always feared being consumed by forces larger than themselves, social, cosmic, emotional. We're wired to see proximity to power as dangerous, yet in the universe, proximity often means transformation. Matter that drifts too close to a star may either vaporize or evolve into plasma coherence, a kind of energy symphony beyond solid form. Perhaps what we call burning is simply the visible phase of becoming something we can't yet classify. So maybe 3I Atlas isn't just an object from another star. Maybe it's a reminder that the universe doesn't only reward survival, it rewards adaptation through surrender. And as the last data traces faded, some scientists asked the most haunting question of all. If the sun didn't destroy 3I Atlas, what exactly did it make of it? After 3I Atlas, something shifted in the scientific imagination. The idea that an interstellar object could approach the sun, withstand its fury, and leave behind coherent electromagnetic signatures sparked an entirely new field of inquiry: stellar resilience physics. Until then, humanity had built its technology around protection, shields, cooling systems, distance. But the data from Atlas inspired a counterintuitive approach. What if survival near a star didn't depend on resisting energy, but using it? Solar physicists began running simulations inspired by the object's pulse cycle, 660 seconds of oscillation, self-regulated by resonance. Laboratories from Japan to Germany started experimenting with ultra-thin metamaterials capable of adaptive thermal reconfiguration, substances that shift their internal structure when exposed to intense heat, much like how 3I Atlas appeared to modulate its surface layers. At NASA's Ames Research Center, engineers proposed an experimental spacecraft concept nicknamed Helioskin, a vessel designed not to block solar radiation, but to ride it, converting photon pressure and magnetic turbulence into propulsion and cooling. Its inspiration? The spectral behavior of 3I Atlas. And beyond the engineering frontier, a subtler transformation was taking place in how scientists defined origin. If 3I Atlas truly came from another star system, then it carried within it the chemical fingerprints of a different kind of cosmic chemistry, one that evolved not in darkness, but in proximity to blazing suns. Astrobiologists began to wonder if life itself could arise from such environments. Could there be forms of organization, perhaps even primitive intelligence, that thrive not in liquid water, but in plasma equilibrium? Not biological, but informational. Patterns encoded in magnetic resonance, surviving through oscillation instead of replication. That speculation once belonged to science fiction. Now, it sits on the edge of experimental physics. Instruments once designed to detect exoplanet atmospheres are being repurposed to scan for coherent magnetoplasma signatures, phenomena that could suggest organized persistence in regions once considered too hostile for structure of any kind. 3I Atlas also forced us to confront the fragility of our definitions. If something from beyond our solar system could survive a brush with the sun, perhaps habitable zones aren't fixed by temperature at all, but by adaptability, the ability of matter to find new balances. We used to map life around the concept of comfort. 3I Atlas points us toward coherence in discomfort, survival through harmony with extremes. And as we develop new materials, new propulsion systems, and new solar probes built not to hide from the sun but to meet it, one quiet question hums through every laboratory. What if the next great leap in space exploration isn't about distance, but about daring to go closer? We like to believe we understand resilience. We define it in human terms: endurance, recovery, the ability to bend without breaking. But 3I Atlas redefined that word on a cosmic scale. It didn't survive by resisting. It survived by transforming, by surrendering to the very force that should have ended it. And in that, there's something deeply human. We, too, orbit our own suns, careers, identities, dreams, fears, each radiating a heat that can both sustain and consume us. We spend our lives building shields, emotional, intellectual, technological. We stay just far enough from the flame to avoid burning, yet something in us still hungers to draw closer, to see what happens when we stop running from intensity and allow ourselves to be remade by it. That's what made 3I Atlas more than an object. It became a mirror, a cosmic metaphor for what happens when we stop defining survival as resistance and start seeing it as transformation. When the data first reached Earth, it didn't just challenge astrophysics. It stirred something older, quieter, a memory in our collective psyche. The idea that fire, destruction, and creation might be the same process seen from different points in time. Ancient myths called it purification. Physics calls it energy transfer. But both speak of the same truth. Some forms of endurance only appear when you stop trying to remain the same. Perhaps 3I Atlas wasn't extraordinary because it was alien. Perhaps it was extraordinary because it behaved the way life behaves, adapting, harmonizing, letting go of form to preserve essence. Even the scientists who analyzed its fading pulse couldn't escape the poetry of it. One researcher from the European Southern Observatory wrote in his final report, "The object is gone, but the rhythm remains." As if something, a code, a pattern, a persistence, had entered our instruments and stayed. That's what real discovery does. It changes not only what we know, but how we feel about knowing. Maybe that's why people all over the world kept following the story long after the object vanished. Because deep down, we recognized ourselves in it. Our fragility, our curiosity, our strange instinct to reach for the impossible even when it burns. And maybe, like Atlas, every one of us carries a rhythm that only reveals its purpose when the pressure becomes unbearable, when we're closest to the fire. Somewhere beyond the inner corona, the ashes of 3I Atlas are drifting now, cold again, invisible to our eyes, yet not forgotten. Its light was brief, its message subtle, but it left behind a trail of data that reads almost like a confession from the universe itself. We expected to watch something die. Instead, we witnessed something become. In that short encounter between an interstellar traveler and our star, nature offered a kind of parable, one written not in words, but in plasma and gravity. The moment 3I Atlas entered the solar fire, it ceased to be what it was. And yet, in some way, it didn't vanish. It adapted its identity to the violence of light. It found equilibrium where equilibrium should be impossible. And maybe that's the quiet message it carried across interstellar space. that endings are only for forms that refuse to change. We are not so different. Every time we're drawn too close to something overwhelming, love, ambition, loss, creation, we have two choices: retreat or transform. Most of us retreat, but once in a while something, or someone, dares to move closer, to let the fire rewrite them. That's what 3i Atlas did. And perhaps that's what the universe has always been trying to teach us through every collapse, every flare, every burst of impossible survival, that even destruction in the right light can be a form of communication. Because the sun didn't erase 3i Atlas, it revealed it. And now, the question burns quietly in us. Do you think 3i Atlas was destroyed by the sun, or transformed for it? Tell me what you believe below.